One, we are live. Okay, so today, chapter 3 test review, okay? I'm going to go slowly. Pay attention. So number one, it's like Jeopardy. These are the answers. These are the zeros. These are the answers, okay? So I'm going to do it on a separate sheet of paper so I have more room, okay? So if I have a 2i, a negative 4, and a square root of 7, okay? Now, we're going to use a little bit of brain power, okay? 2i had to have come from an x squared plus 4. Had to have come from an x squared plus 4. Because when you bring over the 4 and you square root it, that's the only way you can get a 2i. So really, there's actually a negative 2i also, isn't there? But we don't need that. We just need the equation. So x squared plus 4 would make my 2i answer, correct? Yeah. Negative 4 would have come from an x plus 4, correct? Yep. And a square root of 7 would have come from an x squared minus 7. Yep. So here's my f of x equals that polynomial. That's my answer. Well, that's my question, technically. And those would be the zeros. That's all you need to do. Isn't that easy?
Do we have to unfactor it or no?
No, that's it. That's all you need. Because, no, that's not hard. You would get you agree? You'd get a 2i from this one. You guys agree with that? You'd get a negative 4 from this one. And you get a square root of 7 from this one. Everybody thumbs up? Awesome. Okay, number 2. All right, number 2, we're just going to add, all right? So I've got to, that's it. You could if you wanted to, but don't. You know why I say don't? This is correct, and if you make a mistake, Aiden, and you get it wrong, you know, because there's two forms. Let's just stay with the easiest form, okay? 10x cubed plus an 18x squared minus 4x plus a 4x cubed minus a 6x plus a 3x squared, okay? Can you see all that? Well, not really. I'll slide it down here. You just put it there. That might be easier. Okay, so what's the same? So we got a 14x cubed, right? Yeah. Plus a 21x squared.
What?
Mm-hmm.
The 18x squared plus the 3x squared.
Okay, and then minus 10x. Everybody agree?
Yes.
Just add in. Yeah, just add in. These just weren't in order. Okay. Okay. 3. You ready for 3? So for me, when I subtract, I don't like to make mistakes. So I add a negative, right? So I add a negative, make that a negative 3x, a minus 5y, and a positive 15xy. I do that because I am famous for making mistakes. I don't want to make a mistake, so I add the negative. So now I combine the terms, and I'll have a 23xy. Yep. Okay, so I push through the negative, right? Change all of the signs of the second expression, and now I'm going to add like terms. Those are the same, xy, so I'm going to get a 23xy. I'm going to add my x's and get a negative 18x, and I'm going to add my y's and get a positive 7y. That's all. Okay, number 4. Yeah, I'll wait for you. Then number 4, I'm going to rewrite. There's no room on my paper for number 4, so I'll have to do number 4 out.
Can you combine the x, y?
I can't. No, they're different.
You can't like multiply them too.
You can multiply, yeah.
Remember, what's in the bag?
No, but like no, but I mean like the 18x times the 7y.
They're different.
Oh, yeah.
That's exactly what's in the bag, right?
I'm sorry, Aiden.
Someone should just say that on the
Okay.
show.
Okay, ready? Okay, let's take a look at number 4, okay? Number 4, here we go. 4, I'm going to do 4 out on a piece of paper because it's too big. X to the 6th minus 1 times x cubed minus 4x plus 3. So you add exponents. Add exponents. So you ready?
X to the 9th.
X to the 9th.
9.
Minus 4x to the 7th plus 3x to the 6th minus a 1x to the 3rd plus a 4x minus 3.
Oh, you're going faster, baby.
And that's it. Cannot combine any terms because they're not the same. Okay. Number 5.
Why can't you give us a problem like that?
That's easy, isn't it?
Yeah. Oh, no, this one's gonna be. This is long.
It's still long.
Okay, so I'm going to do, ready? I'm going to do those two first. Okay? Makes it easier for me to do the back two first and then multiply times the front one. For me personally, okay? Does not matter. It does not matter order. For me, I'm going to do these two first. I'm going to get a x squared minus 3x plus a 5x minus 15. I'll let you catch up, all right? Which would be an x squared plus a 2x minus a 15. Okay, let's bring this one back down. 3x plus 2. Okay, now let's do it again. 3x cubed plus 6x squared minus a 45x plus a 2x squared, line them up, plus a 4x minus 30.
And you can combine x squared and x.
Yeah, 3x cubed plus 8x squared minus a 41x minus 30, and we're done. Okay.
Where's the answer?
Okay, 6. Let's factor. So on 6, I'm going to factor x squared, because that'll make an x to the 4th, right?
Wait, how'd you get?
Minus 9 minus 1.
Minus 1, minus 9, same thing. Sorry, Cameron, I said backwards, but same thing, right? Totally agree. Factor again. X plus 1, x minus 1 with a x plus 3 and an x minus 3. So what you find in here is that oftentimes, since this is Algebra 2, we factor twice, right? If we're in Algebra 1 or Geometry, only factor once, right? That's the easy stuff. We're in a level up from that. That's why we're factoring twice, okay?
Does that mean pre-calc we can factor 3 times?
Yeah. Okay.
Just keep going up and up.
Okay, B. How about B? What do you think?
Combine.
Yeah, let's group them. Let's group them.
Wait, go slow.
I will. Actually, I might even do it on a separate sheet of paper. How's that? Number 5. What was the answer for 5?
3x cubed plus 8x squared.
Okay. All right. 6B. 4x cubed minus 2x squared minus 10x plus 5. And we're going to group them, okay? They have a 2x squared in common, okay? I'd be left with a 2x minus 1. Second group has a negative 5 in common. I'd have a 2x minus 1. Okay, the two groups have a 2x minus 1 in common, and we'd be left with a 2x squared minus 5, and that's it. Now, there's no equal sign, no mini equations. There's no equal sign. You're done. There's no equal sign. Don't solve. Just factor. Done. Okay? No equal sign. Don't solve. Yeah, Derek?
Could you, and then for a 2x squared minus 5, could you do like a 2 2x and a 2x and a square root of 5 and a square root of 5?
If this 2, well, the 2 makes it a problem, okay? The 2 makes it a
Or
problem.
the square root of 2x squared?
Yeah, actually, you could do that. You could go square root of 2x plus square root of 5, yes. And the square root of 2x minus square root of 5, yes. You could do that. But we're not going to do that, okay? You're completely correct, Derek. Okay, number... Okay, 7. You guys ready for 7? Okay, 7. Find the zeros. Number 7. X cubed plus 125 equals 0, right? How many zeros?
3.
Good. So, let's get 3 by using this form.
And that will be up tomorrow.
Oh, of course. And that'll be there too, okay? So, this is the same thing as x cubed plus a 5 cubed, right? So my a is x and my b is 5, right? I'm going to write the formula. A plus b, a squared minus ab plus b squared. And it's on the board. I won't erase it. It's there, okay? But I'm going to write it up there anyway, okay? So all I got to do is put my x and my 5 into my formula. So, okay, here we go. So I'm going to have a x plus 5 times an x squared minus a 5x plus a 25. Okay, how am I doing? Mini equations. Now I really do solve. It's got an equal 0, right? So I am going to solve. Okay, I'm going to go to my mini equations.
So
Yes.
X equals -5.
Yep. I got x plus 5 equals 0. And Aiden, you're totally right. -5 is one of my answers. Cameron said the other. So this will not factor. So we have to use a quadratic form, okay? So, quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So if it won't factor, you have to use a quadratic formula, sorry. A is 1, b is -5, and c is 25, right? So, negative b, which is a -5 or a +5, right? -5 plus or minus the square root of a -5 squared. We have -4 times 1 times c. Yeah.
Isn't -5 plus or minus?
Yes,
-5, right? -5. All over 2 times 1. But Derek, always question me because I do make mistakes, don't I? Okay. How am I doing?
Wonderful.
5 plus or minus positive 25 minus 100 over 2. Five plus or minus square root of a -75 over 2.
Use 25.
Yeah, I'm going to use some side work. Yeah, exactly. We're going to do some side work. You okay with some side work? So square root of a -75, some side work, is the same thing as the square root of 25, square root of 3, square root of -1, right? Which is 5 square root of 3i, right?
Yeah.
So let's put that right there, okay? So
Inside the square root.
the I, yeah, and so what you see, man, you ask good questions. So you see in a lot of books, Derek, is they write it like that for exactly what you just said. Okay? They'll put the I there so that you're not confused that the I is inside the square root. Okay?
Oh, yeah, yeah.
But don't you kind of have the line that comes down from the square root?
Right, and the reason I like it here is because by theory, it's written A plus BI, so B is technically 5 squared to 3, then I, okay? But it doesn't matter, right? Doesn't matter. You'll see it in a lot of books written like this, okay? So anyway, last but not least, we'll go 5 halves plus or minus 5 halves square root of 3I. How's that? Or you can put the I there. It does not matter. Okay? Can you do that tomorrow?
Yes.
I heard a no. Heard a yes.
Try.
You can try.
Probably not.
Okay, all right. Well, with a little luck, we'll get it right, okay? Okay, number B. Okay, B's not too bad. Yeah, let's do B.
Everyone gets to cheat off Tim.
All right. Okay, B, we've got a 2x cubed plus a 5x equals 11x squared. Okay, what do you think we should do?
We should
Subtract 11x.
Bring it right there. You guys agree? Bring it right there.
Yeah.
Put it right in the middle. So I'll have a 2x cubed minus 11x squared plus 5x equals 0, right? No, it will factor.
Because you have a 2.
The 2.
Okay.
-5 and -1.
So it's the first thing we should do, though.
Pull out an X.
There you go. Let's pull out an x. 2x squared minus 11x plus 5. However, if you do use the quadratic formula, it will work, and you will get the right answer. Okay, I'll say it again. You can use the quadratic formula. But if it factors, why would we want to, right? It does factor, right? 2x and x, because that'll make a 2x squared, right? I'm going to put my 5 here and my 1 here, because 1 times 5 is 5. But, remember my double smiley? See my 10 and my 1. See the 10 and the 1 makes 11, but I need a negative 11, so I'll go negative, negative, okay? Now we're not done, because we're solving, right? We're solving. So, 3 answers, right? Mini equations, x equals 0. 2x minus 1 equals 0. X minus 5 equals 0, right? Boom, that one's done. There's one answer. 2x equals 1, because I added 1. Divide by 2. 1/2. Boy, I tell you, next semester it's going to be hard because I'll have an algebra 1, and I know it's going to be hard for me to slow down. X
2 years ago.
equals 5. Because I know some kids go, well, Miss Davies, how'd you get the 5? I'm like, oh, just kill me, please.
Is that weird in 7th grade?
Yeah, pretty much. Yeah.
Mr. Bard. Oh, no, Mr. Bard's not there.
Thing is, I was trying to figure it out and looking for it and trying to out, but my
In
hands
7th grade, and then after that we learned a little more in pre-algebra.
All you had to do was listen to Mrs. Hab.
Pre-algebra.
Oh,
Mr. Bard.
Senior Bard.
Mr. Davis.
Yes.
Bard was a big Bard.
Hey. We're not going to call Mr. Bard any good or bad names. His son is sitting right here, so let's be kind, okay?
Mr. Bard's a native.
Yeah. And you're being recorded, so.
He's gonna expose y'all. He knows your.
All right, so
He knows your boys.
Where's that $5?
here we go.
I like your geog.
So when Owen opens up this file, and Mr. Bard listens to it, he goes, "Oh, so that's what they think of me, huh?" Okay, 8. Okay, first of all, so we want zeros, right? Let's get zeros first. How many zeros are there?
You're going too fast,
There's
Mr. Davies.
3.
3, right?
Take out an x.
Okay, there are 3 zeros, right? So we got to find zeros first. So we take out an x. X squared plus a 1x minus 6, right?
Wait.
It does.
Factor again, right? Factor again. X plus 3, x minus 2. Yeah.
Yep.
Mini equations. X equals 0, x equals negative 3, and x equals positive 2, right? I can skip that step, right? Algebra 2, I can skip that step, right? I can do that.
Not for me, Mr. Davies.
Those are my zeros, okay? Those are my zeros, right?
One's supposed to get an F on the test.
Yeah. You can't.
So
Great brain.
we can probably graph some of this, right? We can probably graph some of this. Beautiful. Okay. We're going to graph it. I'm going to go x cubed plus x. Oh, doggone it. I'm going to go x. Guys, you want to go outside?
No.
Okay, let's stop so we can get this done. x cubed plus x squared minus 6x. Oh, shoot. Keep hitting the wrong button. 6x. Let's graph it, okay? Okay, it looks like that. I'm going to change my window, make it a little bit taller. Make it a little bit taller, maybe 10 and maybe negative 10. There we go. Okay, so calculate maximum, right? Calculate my max. Left bound, right bound. And I get about a negative 1.8. So I've got a negative 1.8 comma 8.2. And I have a calculate minimum. Left bound.
Do we have to get the minimum maximum right too?
Well, in order to do increasing, decreasing, you do, yeah. Does that make sense? You can't do it without it. And I've got a 1.1 and a negative 4, okay? So let me trace it in. It's going to go something like this. I'm not going to make it perfect because I mostly need my values for increasing and decreasing. Okay, so I've got it. I've got a graph. Max and mins I have. Here's my max. There's my max. So my max is at negative 1.8 to 8.2. My minimum, here's my min, right? My minimum's 1.1, negative 4. Okay, there's my minimum value, right? Top of a hill, bottom of a hill. Super easy, right? Top of a hill is max, bottom of a hill, min, okay? Increasing, decreasing. So,
I have a question, Mr. Dick.
yes.
So, do we have to use the calculator to find max and min, or is there a way to do it without?
You actually will learn how to do it in calculus, to do it without a calculator. But that's when you get to, and it's not hard. It's really not hard at all, but
Well, isn't
why
it
don't
just
we
like a
learn it here?
parabola?
because it's
Parabola,
calculus.
basically?
Huh?
Isn't it just like a mini parabola?
Kind of. It is kind of like a mini parabola, yeah. And so it's not that difficult. Come on in at lunch sometime and I'll teach you,
Does
okay?
that mean we could figure it out with the stuff that we know?
Yes, but you have to know calculus. You have to know the trick to calculus. Come on in at lunch and I'll show you, okay? So, it is increasing, right? From negative infinity to a negative 1.8. Okay, I'll show you, okay? We're going uphill from here to here, okay? And that is a negative 1.8. It's the x value, that's the x value, okay? It's going uphill to there. It's also going uphill from here to infinity, right? So from a 1.1, so it's also increasing from a 1.1 to a positive infinity, okay? Decreasing. Slide that over here. Yeah. It's decreasing. We're going downhill from here to there. And it's the x values, right? So it's from a negative 1.8 to a positive 1.1, okay? So it's decreasing from a negative 1.8 to a 1.1. Set notation, Brittany, it would be a negative 1.8 greater than x greater than a 1.1.
Doesn't
And-
matter, write it backwards. And 1.1 is less than x. Less than
I wouldn't count it wrong, but it's not correct because you've got to go from left to right.
Okay.
Okay? You're not wrong. It's a matter of writing it in the correct form.
Okay.
And this one would be, Brittany, my negative 1.8 is less than x, which is less than my 1.1, okay? All right. Thumbs up. You don't have to do that. You just have to use words, okay? Words are fine for me. In Algebra 2, you just have to say, where is it going uphill, where is it going down, okay? In calculus, you're going to have to say it differently, okay? All right, moving on, okay?
That was a big fat problem.
Yeah. All right. Number 9, do you have a calculator handy? Okay, we're going to use our stat button. And it's going to be cubic, okay? It will be cubic, okay? This is not hard. It's the same stuff we've been doing. The only difference is we just go to, instead of our quadratic reg, instead of our linear reg, we go to a cubic reg. Does that make sense?
Right below del.
Yeah. So, all right.
Go to calculate and stat.
Let's go to stat first. Yeah. Let's edit.
Just edit.
Let's edit first. Let's put the numbers in. Clear. Okay. So I'm going to put my numbers in. I went to stat. Am I going too fast? Went to stat. We've done this before, right? So we're going to put in our numbers. I'm going to go 1, Yeah, clear first. 2, 3, 4, 5, 6, right? You guys got it? And then 13, 22, 49, 106, 205, 358, right?
I don't know if it's quadratic.
I'm going to tell you it's cubic. You'll see it. It's cubic. I'll tell you tomorrow that it's cubic, okay? So let's go ahead and go to our stat, calculate, right? Now, we want to do the cubic. We want to do the cubic reg. Okay, we want to do cubic reg. Okay, so I want to do the cubic. I want to do that one right there. So go down to my cubic regression.
Enter.
Enter, right? I got to do L1. I got an old calculator, L2. I'm going to tell you. It's cubic. Enter, and then here's what I get. Oh, it's a nice R squared value. Look at that. It's exactly cubic, isn't
I
it?
just pressed enter.
Right, I have an old calculator, so I had to do a little bit more work than you guys did, right? I've got the old model, so the old model took a little bit more work, but I know how
What
to
is
deal
that?
with
So then the standard error for
What is
me
that
is
one
0.
button you press to turn on? the-
Yeah,
it.
they are
Right,
too.
so if you don't have it, so go to your catalog.
Oh, and go
You want
to
to find the diagnostics on if you don't have it. So it's a good fit. I got an R squared of 1, and I got really nice coefficients, didn't I?
Yeah.
So cubics are a really good fit. You guys agree? So my answer would be, my answer is going to be a y equals a 2x cubed minus a 3x squared plus a 4x plus 10. And I got an R squared of 1, which means R is 1. It's a perfect fit, isn't it? Perfect fit, okay?
Know when you use the different line, like.
I'm going to tell you on the test tomorrow, okay? Because there is a lot to what you just said. Because a lot of times the calculus will fit all sorts of different things, okay? But I'll tell you. But you know for sure that's a good one. You agree? We got R squared equals 1. Dang. It's as good as it gets. Yeah, Brittany?
I was about to like, this is not really like you anymore because of this one, because I didn't read the thing. I was like, I have to do that.
Yeah, but you only have to find that term, don't you? Yeah, and I want to talk about that one. Okay, now, year 12, how do we do year 12?
Just plug it in.
Just plug it in.
I think it's 3,082.
Should we take Cameron's number? I'm going to take Cameron's number.
No, don't take Cameron's number.
Take Cam.
I might have
Buster,
been
it's
All right.
number.
Dustin.
So, hold on, I'll do it.
Buster.
2 times 12 cubed minus 3 times 12 squared plus 4.
Buster, you've been a captain.
3,082.
Dang, I wasn't ready.
Wait, are we actually gonna have to make a scatter?
Yeah, and that we can do that later, okay?
Feel good
Now,
now.
we can do that later. You will have to do a scatter plot, but I think you can probably handle that, right? Scatter plot?
That's pretty
Yeah.
Yeah, you can do it. You can handle the scatter plot, okay? Turn the page.
Why no needle?
Now, number 10. You ready?
Oh, are we doing the?
Watch 10. You only want the third term. Now listen carefully. You only want the third term. We don't care about all the rest. We just want the third term. So fifth row, Pascal's triangle is ready. 1, 5. 21? Anybody have it?
Oh yeah, I have it.
Do you have it? Is it 21?
Yeah, no.
Is it 21 or is it 10? 10, 10, 10, 10. Thank you. 5 and 1. Now, I want
Thank you, Juan Carlos, for giving Mr. Davies
I want that one. I don't care about the rest. I don't care about the whole thing. I just want the third term. Okay? So, first term, second term, third term, fourth, fifth, sixth. I don't care about the rest. I just want this term. So I do know it's going to be a 3x 5, 3x 4, 3x 3, right? 3x 2, 3x1, no 3x's. Now I'm not even writing down the rest of the stuff because I don't care.
Wait,
I only care about the third term. So it's 3x5, 3x4, 3x3, 3x2, which I didn't write down. Who cares? 3x1, who cares? Okay, and then I'm going to have a 2y5, a 2y4, 2y3, and a 2y to the 2, and 2y to the 1, and no 2y's. So I only care about just this one, right? So let's see what I have. Okay, so all the rest doesn't matter. Who cares? Who cares? Who cares, right?
What about, isn't there like a 21 in there somewhere?
Oh, that's the 6th row, I think.
Oh, I get
So
that.
the fifth row goes 1, 5, 10, 10, 5, 1.
I think
No,
so,
but
yeah.
6 would be 1, 6, 15, 20.
Something like that, I know. You've got it, right? Yeah. Aiden's got the 6th row. So, one more time. I only want the third term. First term, second term, third term, fourth, fifth, sixth. We don't care about those. We only want the third term. So that's pretty easy. Should be, right?
So it's the 7th.
So,
3rd.
if I simplify this, I'll have a 10 times a 27x cubed times a 4y to the second. 3 cubed, 27. 4 squared, 4, okay? Which should give me an answer of, I don't know, hold on, I'll tell you a second. 10 times 27 times 4 is a 1080 x to the third y squared. Okay?
Whoa, wait, how you multiply 10 by 27
Whoa.
by 4?
Yep, that's all I did.
Wait, so that's
Okay, take a look at it. That's our answer. That would be our fifth term. Our first term, blah, blah, who cares? Second term, blah, blah, who cares? Our third term actually is this, which turns out, after we simplify, to be this answer. I cubed my 3. I squared my 2. I multiplied 10 times 27 times 4. 1080 x cubed y squared. We're almost done. We really are.
Is binomial theorem just another name for the triangle? Or-
Yes. Anything, because it's got 2 terms. A
Yeah.
plus b to some power.
Oh, yeah.
2 terms. AB, okay? Now, find the equation. This is going to be easy. All right, you ready? So I have zeros at x equals -2 twice. I have zeros at x equals -2 twice. I have a 0 at x equals 3, and I have a 0 at x equals 6, okay?
Oh, you know if there's 2 point,
That's a double root.
if it switches direction.
Yep. That's, everybody agree that's a double?
What happens if it keeps going straight but there's 3?
Yeah, we call it a cube, and it happened 3 times. And what happens is
know.
it bends a little bit. You'll see it's got a tiny little, it won't go straight through, Chase. It'll go like this. Watch it go shunk, shunk.
What if there's 5? So it goes 1, 2,
Is there ever 5 times in the same?
Or 4.
Yeah, it can happen.
What would that look like?
More exaggerated than the cube.
And with
So
4,
Higher.
it would go
with
like
4,
like that?
Yeah.
Okay.
with
Okay.
4, would it look any different than a
It'd be
square?
flatter. That's all. It'd be flat. It'd be flatter. Okay, all right. Now, let me finish this. Okay, so I know for sure I'd have an answer of, you ready? I'd say y equals x minus 2, x minus 2, x plus, oops, I'm wrong, x plus 2, x plus 2, x minus 3, x minus 6 would give me those answers, correct?
Yeah, you do x plus 2 squared.
Yeah, I want to write that. I like that better. Now, there's some value a in front of here that makes it go through the point 0, 3. Okay? There's some value a that we're going to find that forces it to go through the point 0, 3.
Could you do any other point?
No, because you just get zeros. It wouldn't do any good. Because you just get zeros. You get 0 equals 0. You would. If you put any of the others in, you get 0 equals 0, and that doesn't tell you anything, does it? Chase, think
So
about
is
it.
A the slope?
A is like the slope, yes. We got to be careful when we say slope because it's a curvy line. But yes, A is like the slope.
The intensity of the sequence.
Yeah. So I'm going to go 3 equals A times 0 plus 2 times 0 plus 2 times 0 minus 3 times 0 minus 6, right? 3 equals A times 2 times 2 times negative 3 times negative 6, right? 3 is equal to, 2 times 2 is 4, Is it 72?
Yeah.
Goes 72A. What is 3 divided by 72? 1/18th? Is it 1/18th?
Thanks, Gabe.
3 divided by 72 is it 18th? 24th. So 1/24th. So A is a 1/24th, or just give me a decimal. I don't care. I can take a decimal, but 1/24th is what it reduces to. Yeah, that makes sense.
Big long decimal.
Yeah. So my answer then, let's put the 1/24th right there. Now I do like the way Derek described it, so I'm going to write it Derek's way because I like it that way. Then you're going to see what I'm writing. I'm going to go y equals 1/24th. Derek said, why don't I just write x plus 2 squared? I like that. Times an x minus 3 and an x minus 6. I totally agree. I like that because I don't have to write it twice.
Does it just have to be the y-intercept that we plug in?
Has to be. And Chase, when I'm done recording, I'm going to go through, okay? Okay.
Well, wait, there's another question. Will
Yeah.
there ever be multiple y-intercepts, or are they all functions?
Never until we go away from functions and then think about a circle.
Oh,
Yeah, but then we have to stop talking about functions because it wouldn't be a function, right? Yeah.
Can we, instead of doing it that way, can we like do this like a super formula up into one number?
You could. Yes, you could. Yes, I'm almost done. Yes. What's up?
Why should we use 2 negative 2s instead of doing imaginary?
Because that is exactly -2, isn't it?
Yeah.
And it's not an imaginary. That is -2, okay? Hey, girls, I'm going to try and do this one real quick before you leave, okay? Watch. An x cubed equation looks like this, correct? It does. We are going to move it 1 unit to the right, okay? And 5 units down. 1, 2, 3, 4, 5. And then it's going to be shrunk by 1/2. So it's going to be a little